Okay. Hello, hello, hello. Whew. All right. All right. Hello, hello, hello. Hello. Good morning, Samantha. How are you? What? Meh. Meh. Well, hopefully you'll feel a little less meh today. So, good morning, Hisa. How are you? Yeah, I'm very good actually. Doing well today. Doing pretty good. It's been a it's been an interesting day so far. I'll say that. Been pretty busy this morning with a lot of emails. So, all right, we're gonna wait for maybe another minute or so, and then we'll go ahead and get started. Good morning, Robert. How are you, my friend? How was your weekend? Good. I'm doing very good, my friend. Very, very good. Hopefully, got a few things to talk about here today for sure, but we'll certainly talk about that stuff there, and then we'll get going. So, yeah, what'd you end up doing this weekend, Robert? Sounds like you had a really good weekend. I want in. I want to have what you're having. Okay. Yeah, I watched the Bears game. Me too. Me too. I watched that from start to finish. Oh yeah, that was totally worth it. Oh man, what a game. Oh, we got a fun fact here. That is a very fun fact. I wonder how much larger the caiman can be compared to their other alligator counterparts. I'm going to show you a fun fact of the day. All right. There's my fun fact of the day. Dang. Okay. 880. Wow. It's actually really beefy. It's a beefy boy. It's a chonky boy at 880. Mr. Mr. Evil. What am I teaching in this class, Chase? I am teaching pre-algebra is this class here, Chase. Pre-algebra, my friend. Pre-algebra. I hope you had a good weekend, Chase. Good morning. Did you get my email there, Carissa? Or maybe you did or did not. I don't know. Oh, okay. That's fine. Um, okay. I guess we'll go ahead and get started here. That's cool. No, don't worry about it. Don't worry about it. I'll just tell you outright. So, okay, let's get pure evil. That's awesome, Chase. I'm really happy to hear that, my dude. My dude. You're welcome to sit in here and offer up anything you like. So, man, you're more than welcome to be a part of this class as much as you are this afternoon's class. Anytime. Yeah, I got yours from last night. That's the one I'm referring to. But I'll just tell you outright. That's cool. All right, I'll tell you what. Okay, let's get started today. Welcome back to Tuesday. All right, hopefully everyone nice weekend. Okay, so today I made a little bit of an executive decision, a little bit of a democratic decision as well, and that is that I have extended the homework assignment. Um, I have extended the homework assignments for the test here for chapters 2 and 3. Um, I've extended that out to the 1st of November, and I've extended the test out to Thursday. So I've extended the test out to Thursday and the homework to the 1st of November. So I know a lot of people were asking to get a little extension on the test. So I've granted a 2-day extension on the test to get that finished. Okay, so that should be fine. Chase, where do I turn in my worked problems for the test? For 112, right? Is that what you're referring to? So yeah, you don't have to turn in work for your test. It's whatever, I just take a look at what you did on Alex there. So that's the way I'm rolling. Just letting you know. I hope that makes sense though. Trust me though, there's gonna be possible bonus points though, so for sure. Because Alex just has the score stuff there. Um, all right. Um, when is the midterm? Okay, that's okay. Like I said, I'll take a look at the. If you want to send it to me in a picture format, you can. Just send it to me via email. I'll take a look. I could give you some partial credit if there is something there. So, um, let's see here. Right. When is the midterm? So the chapter 2 and 3 test, Bella, is due on Thursday. I've extended it out until then. The homework, uh, Hey, why not? uh, okay. Thank you. um, so the midterm there, you have the chapter 2 and 3 test, which is due on Thursday, Bella, and the homework is due on the 1st of November. So I extended the test out by a couple days. If you've already done the test there, Bella, then you should be good to go. Um, then there's no midterm. It's just pretty much us taking the tests and then doing the final stuff. So, there's no like midterm test per se. It's just again just following the schedule that we already had planned out from before. So that's pretty much how it goes in this class. I don't really like midterms. I just kind of like to go at my own pace. So, all right. Okay. Are there any other questions before I get started here? Um, Hopefully I've answered a lot of your questions that you may have had around today. Any questions at all from you guys? Bam. All right. None. None. Samantha with a none. Very, very authoritative. Samantha's not taking crap from me today. I see how it is. Okay. I got you. I understand. Okay. Um, all right. So let's talk about, let's go ahead and get started here with the newest material here. So today, what we're going, nothing to be sorry about. I just think it's funny. That's all. I don't mind being shouted at because look, today I was called Mr. Evil and Pure Evil with also my self-professed Mr. Zero Charisma. So if that isn't evil enough and to be deserve to be shouted at, I don't know what is. So we're gonna kind of roll with that. Okay, so what we're gonna do here today, eventually, is we're gonna go ahead and talk about the latter half of the last section here was section 4.4, which was talking about multiplying decimals here, and then we'll also talk about dividing decimals as well here. Today we're going to do the kind of the first half of section 4.5, as there's a lot in section 4.5. It's a pretty chunky section with a lot of different concepts. So we're going to see how far we can get through that as well. All right. But what I want to kind of remind you of is kind of talk about how we did multiplication last time. A lot of you did pick up on it rather well. But let's go ahead and remind ourselves how to do a little bit of multiplication from previous. So we'll go ahead and do a problem here. We'll do go ahead and do this problem. Well, I know we'll start with this one. 11.62 times 4.01. So let's go ahead and do that. Again, one of the things that we talked about here is that the decimal points don't necessarily have to line up. Okay. So again, one of the things that we talked about last week when it came to multiplication of decimals is we first counted out how many decimal places each number had. So let's answer this question here really quick. How many decimal places does 11.62 have? How many decimal places does 11.62 have? Okay, good. That's right. So 2 decimal places. And how about 4.01? How many decimal places does that have? How many decimal places does 4.01 have? So this guy right here. 1? 1. How many? Okay, so remember, the number of decimal places is how many numbers we have to the right of the decimal point. So how many numbers do we have to the right of this decimal point? 2. That's correct. So even if it's a 0, that still counts, okay? If the 0 comes before that number, that still counts. So the number of decimal places that we have here is 2 decimal places. Okay. So we add those two guys together. And we're going to be moving, again, 4 decimal places here at the end of the day. All right, so we have 2 decimal places from the first number and 2 decimal places here from the second number. And we get 4 decimal places overall. All right, next. We go ahead and we talk about, say, all right, well, we want to rewrite this problem here. So again, we're going to put 4 decimal places in our back pocket. We're going to use that at the end of the problem. But what we're going to do here is, of course, take each of these respective numbers here, 11.62 and 4.01, and imagine that the decimal points don't exist. We'll treat them as they were whole numbers. So the first number here would be 1162. Again, just imagining it without the decimal. And the second number here would be 401. And we go ahead and just straight up multiply. So let's multiply here. We get 2, 6, 1, and 1. Take our cross out method here, cross that out. 0 times anything is just 0, so we'll just put zeros here. We'll cross out twice. 4 times 2 is 8. 4 times 6 is 24. 4 times 1 is 4, plus 2 is 6. And 4 times 1 is 4. How do I get the 6? You talking about this 6 right here, Samantha? You're talking about this one here that I underlined? I did 1 times 6. So 1 times 2, 1 times 6, 1 times 1, and 1 times 1. So that's where I got that 6 from. So all I did was just take this one and I'm not sure what kind of question you want to ask. All right. So here we got 1 times 2. You go ahead and ask me a question once I can answer that. So we got 1 times 6, 1 times 1, 1 times 1. All right, we got the bank of zeros here from the 0. And then we got this. So we got 465,962. And remember, we're going to move over 4 decimal places. So we're going to start from the right and move left 4 decimal places. So we got 1, 2, 3, 4. I'm going to put our decimal place right here. So our final answer here from this is 46.5962. Okay? And that's our final answer for that problem. All right? Any questions about that? Oh. Oh, that's what you meant. Okay. Oh. It's like Okay. Okay, cool. All right. All right. Now, this time I'm going to have you guys try a problem. So, let's have you guys try letter D here. So, go ahead and try again 58.6 times 17.4. So, go ahead and take a minute or two and try this particular problem out. Okay? And let's see what you guys get. So again, let's take a minute or two here, and then once you have your answer there, go ahead and post that in the chat, the answer that you got. So go ahead and give that a minute or two. Well, oh, you're right, Carissa. It is. Here we go. Sorry about that. My bad. Okay. 1019.64. All right. All right. So I got a lot of people getting the same answer here. Okay. Very good. Let's go ahead and see if all of you are correct, since all of you have guessed the same thing. Let's take a gander, shall we? All right, and if you didn't get it, in this amount of time frame, don't worry about it. You get a lot of time in which to finish. So again, take your time about how you do things. So we have 1 decimal place here for the first one. We got 1 decimal place here for the second one. So in total, we have 2 decimal places that we're going to have to move. Okay. Now we can go ahead and multiply both of these numbers as is. So we get 58.6. All right, not 58.6. What am I doing? 586 times 174. Okay. So let's go ahead and see what we get here. You get 4 times 6 is 24. All right, carry the 2 here. We got yes, I did, Chase. I did receive that email. We can talk about that later, though. 4 times 8, which is 32. 32 plus 2 is 34. 4 times 5 is 20. 20 plus 3 is 23. Okay, but put our x there. 7 times 6 is 42. 8 times 7 is 56 plus 4, which is 60. Carry the 6. 7 times 5 is 35 plus 6 is 41. Put a couple of things here. And 1 times 586, so we get 6 and 8 and 5. Okay. So let's go ahead and add these together here. We get 4, we get 6, get 9. 2 plus 1, 3 plus 8 is 11. And 1, get 10 here. Okay, so this is what we have here. And now we just move over 2 decimal places to the left. So let's go ahead and do that. So starting all the way on the right, moving left, 2 places, 1 and 2. So that indeed is the correct answer here of 1019.64. Nice. Okay. Any questions about that? Nice job, everybody. All right. Good beans. Okay. So that is pretty much the other couple of examples I wanted to do for multiplication of decimals, just to kind of give you a friendly reminder and, just a few more looks about how we could approach these type of problems. Okay, now we're going to transition here into the very next section, which is section 4.5, which is dividing decimal numbers. So now we've talked about addition, multiplication, and division. Now we're going to talk addition, subtraction, and multiplication. I can't speak today. Now we'll talk about division. Yeah. Okay, let's talk about the keys behind dividing numbers here. And for us to understand that, we're going to look at this problem here. We say take 21.93 and we'll divide it by 3, for example, like in this particular book problem. So I put it up here. I said, okay, if we're dividing decimals up here, we take 21.93 divided by 3. Now this will kind of go back to what we talked about quite a long time ago when we wrote out division problems. We say 21.93 is the dividend. Okay, that's the number that we're dividing. And 3 is what we call the divisor, the number that you are dividing by. But one of the most important parts here in this section that's going to be important is where each of these numbers go when we go ahead and write out this problem. Meaning to say, where does the dividend go and where does the divisor go? So the dividend is the number we are dividing by. Divisor is the number we're dividing and the number we're dividing by, but the divisor here is the number that goes on the outside. The dividend is the number that goes on the inside. So basically, as it looks something like this. Again, if we have 21.93 divided by 3, then 3 is our divisor, so that goes on the outside. Okay, no problem, Chase. I'll talk to you later, buddy. All right? And then we'll have 21.93 here on the inside. All right, so we got 3 on the outside. We got 21.93 on the inside, just like so. So remember, order matters here when it comes to where these numbers go. Again, dividend and divisor. Now, to get division and to understand how division works, let's look at the 2 keys that are going to be the most important in this process. Number 1, key number 1 here, and this is very important. Make sure that the divisor, the number on the outside, is a whole number. So for us to actually do this out, and if we're going to start understanding how this works, we want to make doubly extra sure that the divisor on the number on the outside is a whole number. It's easier to work with whole numbers than it is to not work with whole numbers. So we're going to make it easy on ourselves. Key number 2 here, as you can see here, is to line up the decimals after confirming key number 1. So we first have to confirm we got a whole number there on the outside. And then once we do, then we can line up the decimals just like we did for addition and subtraction for our answer. Okay, and you'll see exactly how that works out here in just a second. Okay. Oops. Come on back. All right. So what I want to show off here next is just to showcase and be like, okay, well, what do you mean by those 2 keys? What does that mean? Well, notice that this is where the decimal point is located. All right. So we're going to go ahead and line that decimal point up exactly where that's located. So I'm just going to put a decimal up here in red, just like so. All right. And then we just do regular division after that. So just do the same old rigmarole that we're pretty much used to at this point. So here we just answer the question, 3 goes into 21, how many times? How many times does 3 go into 21? 3 doesn't go into 2, but it goes into 21. How many times? 7. That's correct. So we do the same old rigmarole. Okay, we just say, hey, 7 times 3 is 21. All right. That's going to be 0. We still bring down the 9. Again, we've already taken care of the decimal point, so we don't have to worry about that for the rest of the problem. We say, okay, 3 goes into 9 how many times? All right, 3 times. Okay, so 3 times 3 is 9. Subtract, we get 0, bring down the 3, and we get 1. Okay, so our final answer here, as you can tell, is 7.31. Okay, so 7.31 here. This is section 4.0. Where is that? I think maybe section 4.5. Section 4.5. I was gonna say section 4.0. What happened there? Oh no. version 4.0, everybody. Maybe back in the day, back in the day replay, right? Maybe the ancient Egyptians were like, yeah, um, yeah, this is math 4.0. Like version 1.0 wasn't so great, but 4.0 was a little bit better. uh, all right. All right, let's do another problem here. Okay. So let's have you guys help me with this one. So we'll do 278 divided by 11. All right. So we'll have 11 out here. Okay, so this is 278.3. Okay. Well, maybe for you, it just depends. Try and give a fair test. So, give me a second here, everybody. I'm going to be right Okay. All right. Sorry for the wait, everybody. That's what happens when oof. Boy, I know I ate something wrong. Whew, boy. All right. That was no fun. All right. Hate when that happens, though. All right. In any case, um, okay. Um, looks like my chair brings in the views. Okay. Uh, okay. Let's take a look here. Well, um, you wouldn't be wrong in that assumption. You would not be wrong. Oh man. Okay. They are called sliders for a reason, right? Slide right in, slide right out. White Castle's great for like 2 in the morning. 2, 3 in the morning, White Castle's great. Okay. Okay. Let's go ahead and see if 25.3 is indeed the answer here. All right. So for what we need to do here, we take 11. 11 goes into 27 here 2 times. So 2 times here, we get 22. Subtract that out, we get 5, and we bring down the 8. So here we get 58. That's going to be 5 here. Again, forgot to put the decimal. Let's put that in right away. 5, that's 55. And then we get 3, bring down the 3. And then we get 3 here, which is correct, 25.3. Okay. All right, and there we go. 25.3 is indeed the correct answer. Very good. Nice job, everybody. Get the yes, yes, yes. Okay. Any questions? Any questions about that? Oh mercy. Okay. No. Okay. No. All right. Okay. Let's take a good look here at our next example. Now, our next example is to divide 1.5 by 8. Okay. So as you see in this example here, kind of in the corner, we're going to divide 1.5 by 8. All right, and we'll talk about why this is a more unique problem here, because we do have to point out a couple of important things. So I'm going to take 1.5 by 8, so 1.5 divided by 8. Okay, now first things first here, okay, everybody? Let me ask this question here really quick. What number goes on the inside and what number goes on the outside? So what number goes on the inside and what number goes on the outside for this problem? What goes on the inside? What goes on the outside here? What number should I put, let's say, outside here? Hmm. 8 on the outside, 1.5 on the inside. I also see 1.5 on the outside. Okay, so I get both answers here. All right, so that's fine. All right. Now, of course, one of those has to be correct, naturally. All right, what else? What do other people think here? What number should go on the outside here? Should it be 8 or should it be 1.5? All right. Okay. So the number that should go here on the outside is indeed going to be 8. Okay. Again, 8 is the divisor here. So since 8 is the divisor, that's what you're dividing by, okay, then that number has to go on the outside. That, of course, makes 1.5 the number that goes on the inside. Now, the reason why, again, it doesn't matter. Again, the thing that people get most confused about, and this is why I asked the question, is people think it's always the bigger number divided by the smaller number. But that's not true. It more depends on the position of where that number is located, whether that's the dividend or the divisor. That is not always the case. No. Think of it this way. Here's another way of thinking about it. If I wrote 1 over 3, I can make the contention that this is 1 divided by 3. So essentially, I have 3 on the outside and 1 on the inside. So it is not true that the smaller number is always on the outside. That is not true. So I want you to get rid of those habits there, because it actually depends on position of the number, not on the numbers themselves. So that's the one thing about math that can be sometimes tricky, is that the positions of the numbers sometimes have greater importance than whatever number that you put into the problem. Any other questions before we move forward? That's why we smooth out these wrinkles, is just for exactly that point. All right. Okay. Mine. Trust me, I'm not trying to. I'm not trying to. trying to be as realistic as possible, obviously. All right. Now, there is one thing in this problem that we're going to have a little bit of trouble with. So let me go ahead and point out what that issue is. Now, if you were to do this problem out, 8 obviously doesn't go into 1. So that part there, I mean, that's a 0. You line up the decimals here just as normal. Now, the problem is that 8 here doesn't go into 15 evenly. That goes into it 1 time. And we do 1 times 8, which is 8, and then we just subtract 15 and 8, and we get 7. But here's what doesn't make any sense. What doesn't make any sense is that if we do, we can't really say 0.1 remainder 7. That doesn't make any sense whatsoever, okay? So what we do need to do here is, of course, we need to continue to divide here. Now, how do we do that? Well, let's go back to the Word document here. It says, so I put a little note here. It says, if you have stuff left over, place as many zeros as you need to the right of the number until you solve the problem on the inside. So, the second one here is, you do not need to go on forever. You can place as many zeros as you want. Oops, wrong thing. You can place as many zeros as you want, say, right here. You can put as many zeros as you want next to that 5. Do you need a bunch of zeros? No, you don't need a bunch of zeros. You don't need to go on forever. Maybe you put like, a few zeros here. So I'll put like 3 of them here. I could add a fourth if I wanted to. But yeah, you can add as many zeros here on the inside as you want. That's still the same representation as 1.5. All right. And all I have to do next is just repeat the process here about just bringing down the 0. And then I can proceed to keep going with the division in this particular circumstance. So it's a 70 divided by 8. So that goes in 8 times here. 8 times 8 is 64. So we get 60 here. 8 goes into 67 times. So you get 56. You have 4. So you have 40. So we put 5. So 0.1875 is going to be our answer for this problem. That's 40 there. Okay, so do you have to? I could have put an extra 0 here, and I may not have to use it whatsoever. But again, you can put as many zeros as you want, as long as, again, you can keep going for as far as you want. until you're satisfied with the answer there as far out as you want to go. All right, so that's one of those things that certainly is very important in a problem like this. Okay, so let's do another problem here. This time I'll have you guys do this problem, and we'll do this together once again after that. So let's do this one here. So we'll take 259.3, 0.5, sorry, not 0.3, divided by 30. So 259.5 divided by 30. So let's take a minute or two and give that problem a try, and let's see how it goes. I just asked you to do this problem here. I know my voice sounds very droning because, math professor thing, but yep, this is the problem I would like you to try. It's like, it's math class, it's so boring. I'm like, okay, I totally get it. I've slept in enough classes to know, so. Okay, we got several different answers here. 83.83, okay. 8.65, all right. In this case, there should not be a remainder. Okay. Okay. We'll take another 30 seconds here, and then we'll see exactly what everybody's got. 8.065, okay. Yeah, you should not have a remainder. Remember, you have to add zeros at the end. That was the purpose here. Remember to add extra zeros there. 8.65, okay. That's okay. Okay. Let's take a look here. Now, if you didn't get it right away, that's okay. That's not a big deal. We'll go ahead and take a look at this problem here, start to finish. Okay. Nap time. I haven't even made it out of class yet. All right. Okay. So, We're going to go ahead and put 30 here on the outside, and we'll put 259.5 here on the inside. Again, we'll add a few zeros here at the end in case if we need them. I start off with 3, but you could start off with as many zeros as you want. Okay, 30 does not go into 2, 30 doesn't go into 25, but 30 does certainly go into 259. That will go in 8 times. So 8 times 30 here is 240. Now we subtract those, we get 195. Remember, we line up these decimal points here. So we get 195. And 30 goes into 195 6 times. So 6 times 30 is 180. So here we get 15. We bring down that next 0 there. 30 goes into 150 5 times. And there we go. We have the end of our problem here. Okay, so 8.65 was indeed the correct answer for this problem. Okay, very good. Nice job. Okay, any questions about that one? Why? Why? I'll tell you why. There, that's your why. Reasons. All right. Okay, so next, let's go ahead and do the next problem here. So in certain problems on the homework here and other certain problems that you'll see possibly later on, is anytime we're dividing decimals of some variety, sometimes we need to round that final answer. So in this particular case, we're going to divide, in this case here, we're going to divide 4.7 by 3, and we're going to round this answer here to the nearest thousandth, okay? And again, we're going to use this technique that we just talked about here of adding zeros in order to see, what our answer would be after we round. Okay. So let's go ahead and take a look at a problem like that. Okay. So let's do this out here. 4.7 divided by 3. So we'll put the 3 here on the outside and 4.7 here on the inside. So we're going to go ahead and have this decimal up here. Now again, we're just going to add some zeros. So I'll add like 3 more zeros. I just add 3 zeros just to start. All right, now one thing that we want to understand here at the very least is that we want to round to the nearest thousandth. Okay, so if we round to the nearest thousandth, okay, how many decimal places is that? How many decimal places is the nearest thousandth? Is it 1 decimal place, 2 decimal place, 3, 4, 5? Okay. Okay, so the answer here in this case, is we got a couple of different answers, is going to be 3 decimal places. Remember that we start at the tenths. Remember there goes the tenths, the hundredths, and then the thousandths. Okay, so tenths, hundredths, thousandths. So that's why it's 3 decimal places here. We don't start at ones. We actually just start at tenths and then work our way up. So tenths, hundredths, thousandths. So 3 decimal places is what we're looking for here in this particular circumstance. So let's go ahead and do the problem out, and let's see what we get. So 3 goes into 4 one time. That's pretty simple. So bring down the 7. All right, 3 goes into 17 how many times? 5, good. Okay. Oh, not quite 3 there. Again, 3 would mean 9. I want 5 here because, again, 5 times 3 is 15. So here I get 2. Bring down the 0. How many times does 3 go into 20? 6. Okay, good. So we do 18 here. Get 2. Bring that down. So as you can see here, you get 20 once again. So you're going to get another 6 up here. That'll be another 18. That'll be 2. That'll be 0. Again, bringing this 0 down. Again, you're going to get another 6, and this will keep repeating forever. So you get 1.5666. So the question here is, if we're rounding this to the nearest thousandth, what will this number round to if we round this number here to the nearest thousandth? 1.5666. If we round it to the nearest thousandth. So 3 decimal places. Okay. 1.566. Okay. Yeah, actually it's the second one, 1.567. 1.567 is the correct answer. Remember, in order for us to round appropriately, we are trying to round to this decimal place right here, the third one, which is where the 6 is located. But remember, for us to round correctly, we need to look at the number to the right of that. The number to the right of that is 5 and above, again in this case 6, so we actually go up by 1 here to 7, and then of course this changes to 0 as a result of rounding. Okay, so that's why it's 1.567, because it goes up by 1 when we go ahead and round it. So that's why you have to do, like, as you can see here, that's why I did kind of 4 numbers here. So I could see what that next number was at the end of the day, and then I can properly round and get my final answer. Okay. All right, any questions about that? All right. This time, let's have you guys give it a try. I want you to still round this answer here to the nearest thousandth. Okay, so we're still going to round this answer here to the nearest thousandth, but again, the numbers will be different here. So we're going to try this one right here, letter C, 10.22 divided by 9. So 10.22 divided by 9 is going to be our question here. So it's 10.22 divided by 9. All right, let's go ahead and give that a go. Round to the nearest thousandth. We'll take a minute, and we'll go ahead and put this together afterwards. Okay. One 1.136. Okay. So I got two of the same answers there. That's good. Let's see if some other people got it, or they got something different. Just depends. Okay. All right. Okay. All right. So got a lot of good answers here. So all the same. So let's see if it indeed is exactly 1.136, or I mean not exactly, but rounded to. So remember, 9 goes out here on the outside. I'm going to put 10.22 here on the inside. We'll add a few zeros. Okay. So 9 goes into 10 once, so that's fine. So that's going to be 9. This is going to line up with our decimal here, so let's put that. Okay, so 10 minus 9 here is 1. So we get 12. Okay, so 9 goes into 12 once. Get 9 here. That's 3 and 2, 32. So that goes in 3 times here. So 3 times, it's going to be 27. So that'll be 5 and 0 for 50. So 50 here. Oh, I should just put those down. Okay. All right, so 50 here is going to be 5 times, okay? 5 times for that case, all right? So we get 45 here. Just give me a second here. So you have 50 here, and once again we get another 5, and this process will keep repeating indefinitely. Now, so our final result here is what we have, well, not our complete final result, but we have 1.355, and again, we want to round to this number here that we circle. Again, looking to the number to the right here. So again, that's 5 or above, and that will indeed give us our final answer of 1.13 So 1.136 is the correct answer in this particular case. Okay. Okay. So right now, as it stands, the homework here, if you're going to keep up with the homework, is sections 4.4 and 4.5. Now, we've only done half of 4.5. We're going to do the other half, which is actually dividing by decimals here. So we're actually going to take a look at that and how to actually navigate those type of problems, as well as order of operations with decimals. We'll also take a look at that, as well as a little bit of optional material in section 4.6. I'm not going to test you over 4.6, but there are a couple of important things that need to be mentioned here nonetheless, as it can help you down the line. So that is the agenda here for the next few days, or at least the next class. All right. So don't forget, remember that the homework is due on November 1st. I extended that, and then I also extended out the test there to Thursday. Okay, so the test has been extended out to Thursday, and yeah, this is again, we're going to finish up the latter half of 4.5 and um, talk about those important topics, and then we'll do a little 4.6 for next go around. So we're all ready to go. All right. Any questions? Okay. Very good then. All right. I wish to thank you all very much for coming out to the stream here once again today. All right. Everybody, you guys make this fun. You make it enjoyable. Thank you. You have a blessed day too. All right. Have a wonderful afternoon slash evening, and I will see you all in a couple of days, okay? All right. Have yourself a great one. We will see you all later. Take care of yourselves. All right. Have a great one, everybody. All right. Bye.